The speed of light remains constant even if there is relative velocity between the light source and the observer. Furthermore, no object can exceed the speed of light. Why is the speed of light always constant? The answer is simple. It is an observational fact in our world. When moving at speeds close to that of light, time dilation and length contraction occur, phenomena confirmed through various experiments and explained by Einstein's principle of the constancy of the speed of light. However, Einstein's principle is a principle and does not explain why the speed of light is constant. Let us consider the underlying reason. While no object can exceed the speed of light in our macroscopic world, the quantum world is different. Quanta exist probabilistically and can, in a probabilistic sense, exist at an infinite distance in an instant. To resolve this contradiction, our space theory re-examines the nature of space-time. In our space, the time and space we recognize do not exist. Instead, the world is composed of vortices generated in a medium called R-aether. We observe these vortices as the time and space of our perception. Next, I will explain how our world is constructed from these vortices. In our space, there is no distance or time. There is only rotation and phase. The direction of rotation has 3 degrees of freedom, corresponding to the 3 dimensions x, y, z of our world, represented by red, green, and blue. The arrows at the center indicate the direction and magnitude of the rotation, which we call the rotation vector. This rotation vector possesses rotational energy. A photon, a particle of light, is a vortex with 3 rotational components x, y, and z. Consider 2 photons colliding in our space. Since our space only consists of rotation and phase, the collision is between phases. For example, consider 2 photons colliding at their y components of the rotation vector. Viewed from rotation vector y, the x and z vectors are orthogonal. Their composite, the rotation vector xc, shown in magenta, is also orthogonal to the y vector. The photon can thus be simplified into 2 rotations, vector y and vector xc. To make the phase progress clear, we can represent rotation vector xc as a phase positioned on the circumference of a larger circle representing rotation vector y. The 2 photons are then superimposed. When the phase progress of the y vectors of 2 photons matches, they interact. If the xc vectors rotate in the same direction, they pass each other. If opposite, they collide in reverse direction. Since the 2 photons are indistinguishable, both cases appear as if the phases pass through each other. This is the world of photons. However, our bodies and instruments are made of atoms, which consist of electrons and quarks. These are also vortices in the R-aether, but unlike photons, their x, y, and z rotation vectors precess like a spinning top due to mutual influence. The angle of precession for electrons and quarks is always 45 degrees. Consequently, there is a 45-degree phase shift between the rotation axes of photons and those of electrons or quarks. Draw a tangent line to the circle of rotation vector y. Then, draw a line from the center of the circle toward the direction of the xc phase until it hits the tangent line. This mathematical process is called projection. This tangent line corresponds to the spatial axis in our spacetime. The circumference of rotation vector y is projected across the entire universe's y-axis. This means the circumference corresponds to the spatial y-axis of the whole universe. This is similar to how a spherical mirror reflects an entire landscape, but in reverse, or how the Mercator projection expands Antarctica. In our space, a photon travels the entire universe every time its phase completes one rotation. The direction of the tangent line, the spatial axis, depends on the observer's relative velocity. The slope of the phase relative to the spatial axis and its orthogonal time axis corresponds to velocity, c equals y/t. In our space, light's velocity can range from 0 to infinity, depending on the phase slope. Why, then, do we observe light and matter moving at a specific constant speed? It is because the rotation vectors of electrons and quarks precess at 45 degrees. Like photons, the phases of electrons and quarks can be projected onto a tangent line, theoretically ranging from 0 to infinite speed. However, there are differences between photons and electrons and quarks. The rotation vector xe of a photon always points in the y-axis direction. However, for electrons and quarks, due to the influence of the precession of the rotation vector y-axis, the central axis of the precession of the rotation vector xe does not always coincide with the y-axis direction. The central axis of the precession is projected by rotating around a direction perpendicular to the y-axis, the center of rotation of the precession of the rotation vector y. Furthermore, the central axis of the precession of the rotation vector xe rotates, while remaining perpendicular to the phase line of the rotation vector y. When overlapping the projected states, the rotation axes of the photon and the quark/electron align only when the speed c equals 1 at a 45-degree phase difference. Interaction is only possible when these axes align. This is why, although they possess speed from 0 to infinity in our space, the speed of light c is always observed as constant. Regarding the speed of matter, the precession of electron/quark rotation vectors creates unevenness, density variations, in how their phases spread through space. The movement speed of this unevenness is what we observe as the velocity of objects, which is always slower than light. This is why electrons and quarks have mass. Even if phases collide at vast distances due to quantum probability, they always collide at a 45-degree phase difference, ensuring the observed speed of light remains constant. This resolves the contradiction between the principle of invariant light speed and probabilistic quantum observations. While our space has no spatial extension, as we know it, the number of rotations is expressed as concentric circles. In our space, light spreads instantly to the whole universe, but only interacts with matter at a constant speed, 45-degree phase difference. Minkowski space converges these infinite speeds into a single velocity, the 45-degree diagonal. It's like the reverse of a Mercator projection, where an infinitesimal point, the pole, is stretched into a line. The circles of rotation vector y in our space are stretched into hyperbolas in Minkowski space. This relationship is equivalent to a circle being projected into a hyperbola via a Poincare disk or Klein disk. The universe is made of the rotation of vortices, and their precession is the reason the speed of light is always observed as constant.